Welcome to Lesson 2, Reflections and Stretches, Part 1, Reflections from the Horizontal and Vertical Axes. Our learning goals for this section of the unit include demonstrating an understanding of the effects of horizontal and vertical compression and stretching on function graphs and their respective equations, apply translations and compressions or stretches to function graphs and their respective equations, demonstrate an understanding of effects of reflections, or sometimes called drawdowns, on function graphs and their respective equations, including reflections with respect to the x-axis, the y-axis, and the line y equals x. Now, if you remember from lesson 1, we've been working with this general formula, y is equal to f of x minus h plus k, where h is a horizontal shift either left or right, and k is a shift up or down. What we're going to be doing is building on this idea and adding more components to this formula so that we can see other things that happen to the graph. So to start off, we need to start off with a definition of invariant points. Now, invariant points are a point on a graph that remains unchanged after a transformation. So an example of that is here. We're starting with the line y equals x, or f of x equals x. And of course, that's just a straight line going through here, right through 0, 0 at the origin. Now, g of x, what we're doing, we're taking the absolute value of f of x, and we get this nice triangle-shaped graph. So what's happened is that all the y values have changed from negative values to positive values. What we actually have here in the positive x-axis are our invariant points. And these are the points that don't change even after the transformation. So really what's happening is we have these two graphs, f of x equals x and y is equal to the absolute value of f of x, kind of laying on top of each other. And you can kind of see the purple tinge of the line there indicate that the lines are following the same graph. So invariant points, points that don't change once you've done a transformation. Now, what we're going to be looking at today is reflections. Reflection is a transformation where each point, the original graph, has an image point resulting from a reflection in a line, and it may change the orientation of a graph while preserving its shape. So you can see on the example on the right here, we have our original graph, f of x is equal to x squared plus 2. And what we've done is taken negative f of x, and it's produced this parabola. Now, the x-axis is acting like a mirror in this circumstance. We still have that y-intercept at 2, now it's at negative 2, and then the parabola just continues down from there. So what you can see is that none of the x values have changed, but all of the y values have become their negative values. Now, if you recall, we have the general formula y equals f of x minus h plus k. Just to review again, h is a horizontal shift left or right, k is a vertical shift up or down. What we're going to be doing is expanding on that idea, and our new general format for the formula will be y is equal to a times f times b x minus h plus k, where a and b are multipliers, and they're either going to stretch or shrink the graph vertically or horizontally. So we have first looking at when the output values y of a function y equals f of x are multiplied by negative 1, the result is y is equal to negative f of x. This means that the value of a becomes negative. Okay, so we have this formula here, this general formula for this parabola, the red one, and it's f of x is equal to x minus 2 squared minus 2 undergoes a reflection with respect to the x-axis, which is our horizontal axis. Now, I just wanted to remind you that if there's no number written here, we can be understood that a in this circumstance would be equal to 1. So if we're going to reflect this graph over the x-axis, we're going to get a new formula. Y is equal to negative times x minus 2 squared plus 2. So nothing in the formula has changed except that multiplier. And you can see that that produces all of the y values have now changed over into their negative values of the original graph. So what happens is we get an exact reflection of the original graph, and you can see that it just continues on your graph. The other thing that can happen is when the output values x of a function y equals f of x are multiplied by -1, the result is y equals f of negative x. In this circumstance, the value of b becomes negative. So this is where we reflect across the y-axis instead, and all the x values will change positive or negative. If you see, we start with our original function again, x minus 2 squared minus 2, that's our red graph here, and it goes through a reflection over the y-axis. So we can get that new formula, f of negative x, or y is equal to negative x minus 2 squared plus 2. And we can see here that it's just an exact reflection across the y-axis. I'm going to show you what this will look like if you're given a question with a graph, f of x. Now in this circumstance, I've given you a table of values with the original points from the graph a through e and asked you to find the image points. So what we do is this. This question is asking us to do a reflection with respect to the x-axis. Now, when we're flipping it vertically from this quadrant down to this one, what we're doing is we're changing all the y values to their negative values. So we get these points, -2, -2, 0, -6, 2, -4, 4, -4, and 6, 0. Notice that 6, 0 is our invariant point. It doesn't change, no change. Okay, so this is what it will look like to graph this out. We'll just take the new points. Now, you won't always be provided a table of values, but you can always create one for yourself if it assists you in being able to figure out the problem. Otherwise, all we're doing is just changing all the y values to their negative. So let's plot this out. -2, -2, having a point here. Oops, excuse me. Down here. 0, -6, 0, -6, 2, -4, 2, -4, 4, -4, and our invariant point, 6, 0. From here, all you do is just connect the lines to create your new graph. We would call this one y equal to negative f of x. Now, below that, I gave you another table. We're going to plot it on the same graph so you can see how the two differ. In this question, we're asking to give a reflection with respect to the y-axis. So all we're doing here is taking the negative of all the x values, and you'll get these new image points from that result. Notice that b prime, that becomes our invariant point. And there's no change. So that will overlap with the original graph. So just moving down page, we're going to graph out this reflection across the y-axis. So we'll start at point 2, +2, 0, +6, -2, +4, -4, +4, and -6, 0. Once you've plotted all your points, you can just connect the lines again. And this will give us our graph. Y is equal to f of -x. And you can see that it's just a reflection across that y-axis. So here we've taken all of our y values and multiplied them by -1. Here we've taken all of our x values and multiplied them by -1. Behind this, you have 5 practice questions that you should work on before class tomorrow. This is your opportunity to get together any questions that you have about the lesson and bring your points for clarification for the start of class tomorrow. I will gladly help you with them.